Two, one. Start.
Hello, everyone, especially Sir Manaloto. And this is our group video presentation for ITL 201 featuring one of the lessons, Polymorphism. Our members, Luis Raphael Ciabal, Miguel Ponce, and yours truly, Jhed, Vincent, Atienza. Now, let's get started.
So let's talk about the brief overview. What we'll show here is one of the key concept of OOP known as the polymorphism. Poly means many and morph means take different forms. So in short, poly means many and morph means form. So in short, many forms. It is an OOP technique where you need to have knowledge of inheritance that we studied last time. Another OOP concept is it as it is utilized in creating a class and making several inherit from the main class, so it can take on many forms. So we're gonna explain that later on. So Zoe, can you talk about more pro- problem it solves?
Alright, now we move on to the problem it solves. Polymorphism essentially addresses and solves these problems. The first one being method overriding, a problem where, when overriding a method, the subclass can replace the superclass entire behavior completely. Meaning, for example, classes, class 1, class 2, class 3, you might end, if you just want to replace class 2 with class 4, you might end up replacing everything with a different number. So the solution would be using the super keyword to call the superclass or main method within the overridden method, preserving the original behavior while extending it. And the second one, method overloading. It has many problems, but its top concern is its ambiguity, especially with how similar types of or implicit conversions. And the parameters are close in type, like int, string, or many of that. You can confuse both the compiler and the developer. So essentially, it's adding more and more to it. Of course, when there's too much, it can overload the compiler and the developer, causing stress. The solution for that is ensuring each overloaded method has unique and distinct parameter lists that avoid implicit type conversions. If methods do multiple tasks, use separate and clear method names to know, like for example, when a car you need to drive, or piano, play, things like that. Now we move on to the second part.
So as you can see here, we have a main class, subject class, and math and science class. So as you can see first the math in the math class and science class, it extends subject and sci. And in order to make it work, it inherits science and math to the subject class. So as you can see here, there is there is a there is a as you can see in this part, subject S equals new science and subject M equals new math. So meaning in one class there are many forms, science and math. So as you can see in the next slide, Zoe, next slide please. As you can see there, the sub the subject science, the topic of the science are part of the earth, and the topic of math is subtraction. So next slide, Zoe. So if we're going to ask us why in the subject class has a another make topic, void make topic, and he says please give topic. So Mr. Shabal will explain how it works. Okay, Mr. Shabal.
So as you can see in the science and math class, there is no void make topic because it has subject to math and science to give a topic. So going to see in the next slide. So, so that's will be the our output next. Conclusion. In conclusion, inheritance is needed to be analyzed and studied to use polymorphism in order for developer and the compiler not to get confused in coding, overriding, and overloading methods. One must use specific descriptive keywords to express clear intent of what they should do in the code. So polymorphism enables programmer to create flexible code that can be extended or modified. Polymorphism facilitates to the interaction between methods and classes, resulting in more consistent, adaptive, and reusable code. That's all.
Thank you very much for listening. Okay, Zoe.